Good afternoon, and welcome to all our viewers and listeners to this one-hour webinar on chemical grouting. I'm Robert Carpenter, editor of Underground Construction Magazine, and we're very proud to partner with industry leader Avanti to produce what we believe will be an important and beneficial discussion about the continuing significance and benefits of chemical grouting in the modern rehabilitation market. Our focus will include reports from a major project at Downers Grove Sanitation District located in Illinois, just outside of Chicago. While grouting has been around for decades, much attention in recent years has been focused on various types of newer sewer rehab technologies. Sometimes overshadowed has been the proven, effective simplicity of chemical grouting. Today we're going to explore applications, case studies, and the complementary nature of this reliable material with other rehab methods. Of course, the title of this session is Proactive Maintenance with Chemical Grout Earns High Rewards, and I firmly believe that at the end of this webinar you'll have a renewed appreciation as to the benefits, practical applications, and economic feasibility of grout for your specific needs and projects. We'll accomplish that by explaining how the next generation of decision makers will come to understand that grouting is a viable repair and maintenance strategy for preserving underground infrastructure, that grouting is complementary to methods such as cured-in-place lining and other alternative technologies, that definitely proactive maintenance always beats reactive repair, and when properly injected, grouting has long-term predictable outcomes. And finally, we'll learn that grouting is a low-cost, high-reward strategy and fundamental to public works projects. We'll have questions, and there'll be plenty of time for those questions, and we certainly want to make this presentation interactive and valuable to you, so we encourage you to submit your questions as they come to mind through the dialog box on the right side of your screen. And actually, some of you may be seeing have a green bar at the top of your slide presentation there, and if you would just click on that, the green tab, and when you select that and go to the right side, or there is a drop-down menu that has Q&A, and if you click on that, there's a place where you can just type in your question and send it to us. So you're going to be asked, too, audience, to participate in 3 poll questions, and we'll play back your collective responses immediately to see how your answer stacks up to others on this session. Let's do that first poll question right now. And that question is simply, what is your role in the industry? And we'd like for you to select either municipal public works, engineering consultant, specialty contractor, an inspector or regulator, or a technology provider. And again, just what is your role in the industry? And I'm not sure if we're going to be able to get that up this time around or not, but we'll certainly share that information when we get it here in the near future, kind of what is the composition of our audience on this. So let's move on then to start our subject matter expert introduction. We've got 4 experts that we think are going to be outstanding in terms of describing the grout questions that we highlighted earlier. We're going to have, speaking today will be Derrick Wold. He's the manager of the Wastewater Group and vice president at Baxter Woodman Consulting Engineers. Derrick has a bachelor's degree in civil engineering from the University of Illinois and a master's from Illinois Institute of Technology. He's a licensed engineer and president of the Illinois section of the Central States WEF chapter. Bob Swirsky, is the sewer system maintenance supervisor at Downers Grove Sanitation District. He's responsible for planning and scheduling all maintenance and condition assessments performed on the sanitary sewer system, as well as administering flow metering, customer service, and private property rehabilitation programs. John Manijak is a project manager with National Power Rodding, a division of Carillon Corporation. He has a bachelor's degree in management from University of Illinois and 14 years of in-field experience with National Power Rodding. Frank Aguilar is technical product manager with Avanti International in Webster, Texas, where he has served for the last 15 years. Prior to Avanti, he was in the oil and gas industry for 22 years, working internationally in 30 countries. He speaks 4 languages and consequently plays a major role with Avanti's international partners. So first up, our speaker will be Bob Swirsky. Bob?
To talk about grouting. Thanks, Robert. I appreciate the opportunity to talk about the district's grouting project as well as some of our other proactive maintenance and repair programs. The Downers Grove Sanitary District is located about 30 miles west of Chicago. We're a special unit of local government, and our service area covers 20 square miles and serves roughly 40,000 people. Our weather conditions are typical for the Midwest. It usually gets pretty wet here in the spring and fall. The district's responsible for the collection and treatment of wastewater from several different communities. We cover most of Downers Grove as well as a few of the surrounding communities. We do operate our own treatment plant that's designed for 11 million gallons a day. And the Downers Grove Sanitary District operates and maintains 9 lift stations. We have 252 miles of sewer that is predominantly 8-inch vitrified clay pipe. The system has an average age of 49 to 50 years. The oldest pipes are 109 years old and typically bedded in clay. We do have an ongoing in-house maintenance program to clean and televise the system. We clean over a quarter of the system annually and televise about 10%. And as a result of our efforts to upgrade the system and eliminate inflow and infiltration, we have a long history of applying many different technologies in our rehab and replacement programs. In the 80s, just for some background, we did several open cut replacement and lining projects, and they didn't show a lot of improvement as far as the reduction of I&I. In the 90s and 2000s, we continued with some large-scale rehabilitation projects in an effort to prolong asset life and reduce inflow and infiltration. These projects included grouting that was done on large and small diameter sewers. The metering data, because we do flow meter, the metering data after these projects definitely showed a reduction in I&I. And I think we have a good handle on the extent of I&I because we do have an ongoing flow metering program, as I said, that we've had in place for several years. So we are able to gauge how well our mitigation efforts are working. And it's because of this metering program and because of our in-house cleaning and televising program that we already had areas identified where there were no significant structural problems and where our flow metering had shown high I&I numbers. So when the ARA funding came along, we already had a list of several areas that were really good candidates for some preventative maintenance grouting. The results that we wanted from the grouting work included the sealing of manholes, the testing and sealing of joints on the main lines, and the sealing of the lateral connections. Grouting was selected based on these criteria and the positive I&I results where we had reduction from previous grouting projects. And now I'll hand it over to Derrick.
Thanks, Bob. As mentioned, I'm with Baxter Woodman Engineers and was the project manager for the Downers Grove Sanitary District project. I'd like to share some thoughts from the engineer's perspective on the project. First, I'd like to talk a little bit about the district's programs that focus on the collection system. There are a number of programs that they have that rehabilitate the collection system, and the one we were talking about today has 3 goals. Those goals are to reduce I&I. Their wastewater treatment plant experiences peak flows in excess of 10 times the average daily flow, and overflows and basement backups do occur in the collection system. The second goal of this program is to extend the life of the pipes. Much of the collection system is clay pipe. We reviewed the televising records, and the pipe is in generally good condition, but is often subject to root intrusion and leaking joints. The third goal of the district's program is to reduce maintenance. By sealing the joints, the district's crews can be freed up to perform other tasks rather than root removal. I'd like to take a minute to discuss the strategic value of the district's flow basins in determining the scope of the project. The district has 149 flow basins that each include approximately 8,000 feet of sewer pipe. The basins have been continuously monitored with flow meters since 1996. The district also maintains an extensive GIS that includes information such as pipe age, number of SSOs, and basement backups in each of the basins, and the peak flow I&I in each basin. The basins are prioritized for rehabilitation using this information, and for the project we're discussing today, we worked with the district to select 15 basins for rehabilitation. This next slide is a map of the district's basins with the 15 basins that were included in the rehab project color-coded by severity of I&I. The darker colored basins have more I&I, the lighter basins have less I&I. The basins are each assigned an I&I number, which is essentially the calculation of the I&I in gallons per minute per lineal foot of sewer per inch of rainfall. And because we have over 15 years of flow metering data, we have a lot of confidence in the severity of I&I in each basin and can make intelligent decisions on where the next basins we should go for rehabilitation. Over the years, the district has used a number of rehabilitation methods with varying degrees of success. These methods have included open cut replacement, cured in place pipe, pipe bursting, and grouting. And for the project we're discussing today, the district and the engineers chose to use chemical grout as the most cost-effective method to achieve the previously discussed goals. The district did a major project in the late 1990s where they sealed a number of joints on a trunk sewer line. We went back 5 years later, and 97% of those joints passed. So we're very confident in the longevity of the pipe sealing and grouting. Funding for the project was obtained through the Economic Stimulus Package, the American Recovery and Reinvestment Act of 2009. A loan was secured from the Illinois EPA at a rate of 0% interest with a 25% grant. Because of these terms of the loan, the competition was great, and the project had to be shovel-ready. In addition, the Illinois EPA had to approve grouting as a permanent rehabilitation solution. I'd like to finish by touching on the specifications for the project. First, the contractor was required to clean and televise the sewers prior to grouting to confirm that there were no structural deficiencies. The sewers were then grouted with an acrylamide grout complying with ASTM F2304. The joints were tested after grouting to confirm that they held pressure and no longer leaked. And I think what's unique to this project is that in addition to the testing during the grouting project, the specifications also called for a test after a 3-year warranty period that includes all joints and lateral connections within a test area that includes approximately 15% of the lineal feet contained in the original project. If the failure rate in that test area is over 5% or more of the joints, an additional test area of equivalent size will be retested, and that warranty work will be happening next spring. So with that, I'd like to turn it over to John from National Power Rodding.
Thanks, Derrick. Just a little bit about National Power Rodding. We're a part of the Carillon Corporation, headquartered in Chicago and established in 1949. We pioneered the use of chemical grout for sealing sewers. Today, we are still the nation's largest chemical grouting group, serving every state in the U.S. The Downers Grove Sanitary District AARA project covered a total of 112,000 lineal feet in non-lined 8-inch through 24-inch pipe located in 15 separate sanitary basins. There were a total of 24,600 mainline joints tested, 2,100 lateral connections tested, and 440 manholes to be sealed. The project began in December of 2009 and ran consecutively 8 months, completing in August of 2010. We kept a total of 3 grouting crews on site throughout the project. Moving systematically from north to south, we kept all 3 crews within the same basin until it was complete. This allowed the district to only need 1 inspector on site to cover all the crews for the length of the entire project. Of all the lines that were cleaned and televised prior to grouting, all of the lines were cleaned and televised prior to grouting. After televising, the crew then determined if the lines were in good structural condition and a good candidate for grouting. Also before grouting, we removed all the roots, the mineral deposits, and any protruding taps. Of the 24,000 mainline joints tested, we had a failure rate of 25%. Each joint that failed took an average of 3 gallons to seal. With the presence of roots in many of the lines that we saw in the pre-televising stage, we added a root-killing additive to our grout in order to prevent them from coming back. We also came across an area that at one time was a swampy area. The pipe had 2-foot joints and virtually every joint failed. For this area, we added a diatomaceous earth additive to the grout in order to give it a heavier consistency. Of the 2,100 lateral connections tested, we had a failure rate of 60%. We used a 4-foot sock to test and seal not only the joint at the main line, but also the first 2 to 3 joints of the lateral. Each failed lateral took an average of 3 gallons to seal. The project initially bid having 440 manholes to be sealed by creating a grout curtain around the structure. Once we got into the project, we quickly realized that the ground around the manhole was not ideal for grouting. Because they used a large rock for the backfill, the manholes were taking an extensive amount of grout to create that curtain. Not being very cost effective, we suggested switching to a concrete liner. There were also 6,200 lineal feet of 24-inch concrete sewer line that had extensive hydrogen sulfide damage. The operators saw this during the pre-televising stage, and after reviewing the video, the engineers and the district agreed that this particular pipe would be better suited to be lined than grouted. It was taken off the project and then later bid as a cured-in-place project. The important thing to remember is this, that whenever you work on a project, the engineer, the owner, and the contractor should act as one team with one goal, and that is to produce the best results. While the contract may be only set for one item, another solution may be best. Cooperation and teamwork will win every single time. And with that, I'm going to turn it over to Frank.
Thank you, John. I will be discussing today how the utility and storm trench systems impact sewer infiltration in every city of any size and in every part of the country, and how they are interconnected in some way. What you're seeing now is an EPA drawing that you might have seen before, and it's just showing the complex nature of our underground systems. Here's a more up-to-date cutaway image of what an underground system may look like today. Similar points of infiltration. You have your trench water, you have your faulty manholes, you have your leaking sewer joints, you have root penetration, you have leaking surface laterals. In this image, originally sketched by Peter Keefe, it shows us just how the underground storm and sewer trenches work together. When these pipe systems are put in place, a French drain effect is created around the pipe. As you can see, the storm pipe is full of water, the joints are now leaking, and the trench is now draining into the lower sewer trench. In this slide, we see a cross-section showing the main components of the storm sewer over the deeper sewer system. The brown lines reflect the sewer pipes, and the green colors reflecting groundwater that's typically found in the soil embedding around the pipe. This is an image of a major rainstorm or snow melting event, and you see how the hydraulics of the trench water drive sewer infiltration. Imagine these pipes are not just isolated pipes in the ground. It is really a trench system. You have groundwater, you have inflow, and that's reflected in the green and the blue colors. So you see the water coming in there. Once the water level in the storm and sewer system rises, there's increased water head pressure. The increased water head pressure drives exfiltration from both sewer and sanitary systems to open cracks, joints, connections, and manholes. When the system gets surcharged, this begins to break down the bedding soil, which is the fines and sediment that you find during pipe inspection. As more fines are lost, there is a more destabilizing soil environment for the pipe. The pipe begins to move, the pipes begin to lose alignment, and then the joints break open. Here we have the underground water image. You see the draining down effect. These channels have developed over time, moving water to its lowest level. If the storm continues, both the sanitary pipe and trench system become surcharged. The increased water head pressure just drives more water into the pipe trenches. This is an intersection of the service lateral trench and the main sewer trench. You see that we only have one trench system with a lot of arms. When the sewer main and trench surcharge, the laterals also flood. So when you talk about rehabbing, you can't just say we are going to grout the mains. You have to ask, where is the water coming from? So after the storm stops, the water begins to drain from the system, but over time you've lost bedding soil around the pipes and structures. These problems do not occur overnight. It has taken years to develop these underground conditions. From the very first rain event, these underground channels continue to wash away soil. As this continues, more soil and bedding support is removed, further destabilizing your underground structures. And as this scenario worsens, you begin to see how the underground support system of pipes and structures is weakened. The next slide would show this is an example of a worst-case scenario. And this is sometimes the first evidence that you have an underground problem. Out of sight, out of mind is a real problem when it comes to our underground structures. We did not create this problem, but we have inherited it. What's our role as engineers, as contractors, as decision makers? We can dig and replace the aged infrastructure, but it's not really feasible for most municipalities. Rehabbing structurally sound pipe is the best option. Today we have a number of choices, but making the correct one is crucial. You can pipe burst, you can CIPP, you can line. These are all important technologies and all have two things in common. They are all structural repairs and for the most part require a dry environment before being installed. Chemical grouting, the only non-structural repair on this list, is in fact a complementary technology for all these alternatives and the only technology specifically designed to stop infiltration. These other technologies do not stop infiltration. Chemical grouting is a pressure injection of a plural component resin into the soil to stop I&I while stabilizing the soil around the structure. If there is one image that you take from this presentation, it is the various stages of pipe decay. At stage 1 and 2, chemical grout can extend the life of our system. But at stage 3, we're faced with making structural repairs, which can be anywhere between 3 and 10 times the cost of proactively maintaining and sealing our entire system with chemical grout to stop I&I. And with that, I'll hand off to Robert.
Thank you. I already have our first question here, and I think it's probably best to pass that off to John Manijak. Possibly Bob or Derrick may want to pitch in on this. And the question is, was the cost of the warranty requirement inclusive to grouting costs or a separate bid item? And if so, how much did the additional warranty testing cost?
Well, it was an additional item. It was an option that was available to the district if they wanted us to come back and retest. I know that the price to retest was fairly low compared to the rest of the project itself. I don't know if Bob, if you knew the number, but the testing itself can be worked into the original pricing. It can be worked as a separate item.
I don't remember the amount, John. I don't recall it, but I know that it was a separate line item at a set amount, and it's based on the passing of the percentage that Derrick mentioned. And if that's not achieved, then it goes to the next additional testing, I believe, for no additional cost till you achieve the I think it was 5%, less than 5% failure.
Yeah, it was a lump sum amount that we had to meet the the warranty percentage at that point. So we would keep testing, keep sealing if we didn't pass that percentage.
Yeah, that is correct.
All right, thank you, gentlemen. And before we get into our next polling question, I wanted to give you the results as promised from the first polling question, which was, what is your role in the industry? 40% of our listeners and viewers out there are from municipal public works, and 34% are in consulting engineers. With that, we'll move on to the next interactive question, which is simply, what rehabilitation method do you have the most experience with? And pick one: dig and replace, lining, pipe bursting, or chemical grouting. Just which method do you have the most experience with? And as before, we'll report those results back to you shortly when everybody's had a chance to respond. And now we'll move on to Derrick, who's going to talk about benefits.
Yeah, thanks, Robert. I would just like to take a couple minutes and discuss the benefits of the project at Downers Grove Sanitary District. So first, the question that probably everyone has is, how much I&I was reduced by the grouting project? And as mentioned, the district has extensive flow monitoring data over the past 15 years, and using the post-rehabilitation flow meter data, we can confidently say that the peak flows were reduced by an average of 21%. So the next figure here is that map that we saw earlier. As a refresher, it shows the severity of I&I in each basin, with the darker shaded basins receiving more I&I than the lighter shaded basins. The data prior to rehabilitation is shown on this figure. And then the data after grouting is shown on the next figure. And these maps give a nice visual display of the reduction in I&I, and you can see the change in color before and after the grouting project. In graphical format, we are showing the pre-rehabilitation I&I in blue, the post-rehabilitation I&I in red. On the y-axis is the I&I number, which again is the gallons per minute per lineal foot of pipe per inch of rainfall in each basin. And the x-axis lists the 15 basins that were subject to the rehabilitation project. And on average, the reduction was 21%. In the several basins that did not experience this amount of I&I reduction, the district is performing house inspections and finding that much of the I&I in these basins are actually on private property. So again, the benefits of the project include extending the life of the clay pipe, which was in good overall condition, but had joint leakage and root intrusion. The benefit of inhibiting the roots was decreased maintenance activities and free up crews to perform other tasks. And then finally, to reduce inflow and infiltration. And we looked at the project costs. The $3 million project in Downers Grove Sanitary District equates to about 222 gallons per minute of I&I removed on a peak flow basis. This I&I reduction avoids having to construct trunk sewers, pump stations, and treatment tanks for the excess flow, which have cost in the ballpark of 10 times the amount of spent on grouting, or about $30 million. So in our minds, this was a very successful project. And to talk more about that, I'll turn it back over to Bob.
Thanks, Derrick. The district does anticipate a number of benefits from this project because the flow metering has already indicated that reduction. We anticipate the stabilization of the soils around the pipe, that they'll extend the life of that pipe, and also the reduction in root growth is going to help with maintenance because it'll make the need for increased frequency of root cutting less likely in the future. The long-term environmental benefits of the I&I removal, I think, will include increased protection against mainline surcharges that would cause manhole overflows, as well as the elimination of backups into basements. And there you see an overflow in basements. These people, we did have a big storm back in April, and you try to explain to those people about sanitary trenches and transference, but all they see is that you failed to deliver your expected level of service. So we have we've developed several programs that eliminate I&I on private property and benefit the customers as well. We have a repair assistance program that allows us to do repairs on private property for homeowners having sewer backup issues, and a program that offers cost sharing to homeowners that want to upgrade to an overhead sewer. And these proactive programs, they do result in improved customer relations. And all of the programs allow us to assist customers while also identifying and eliminating private property I&I. And we believe that the benefit of being proactive is that it enables you to get ahead of a number of the maintenance issues so that you're in a better position to create these innovative programs to benefit your system and your customers. This is a representation of if you're not being proactive, you're just treading water. The main program we have for reducing I&I is our private property I&I removal program. It's a program that we developed along with Baxter Woodman, and we've been able to totally rehabilitate a targeted flow metering basin. In the last basin that we did, we used a combination of open cut replacement and grouting to address the issues in the public main lines. And then we rehabilitated 173 building services in this area, both on public and private property. We were able to install cleanouts on each service line, and then the service was grouted using a lateral packer from the main line back up to the transition, up to the house in most cases. So that in that way we were able to seal up the sewers on public and private property. The next step for Downers Grove Sanitary District, we're continuing with our private property I&I removal in a couple of new target basins, starting our investigation. And for me personally, as the sewer system maintenance supervisor, I would like to start an ongoing in-house maintenance grouting program that would routinely move through the system like we do with cleaning and televising, testing and sealing joints. So with that, I'll pass it over to John.
Thanks, Bob. Chemical grouting. It is a very underused technology. It's had its roots in the 50s. It was used extensively during the 60s and 70s. Chemical grout usage dropped dramatically during the late 80s and early 90s due to the mainstream use of cured-in-place pipe. Where is the evolution of chemical grout? It's not in the equipment, and it's not in the chemicals, and it's not in the way in which we test or we seal. Where I see the most change in chemical grouting is in the acceptance at the engineering level. It's in the thoughts of the decision makers and the engineers. Given today's decreasing budgets and the increasing pressure to eliminate infiltration and sanitary sewer overflows, chemical grout has a perfect fit. It is the only technology specifically designed to eliminate infiltration. Over the years, chemical grout has gained the reputation of being a bandage. This cannot be further from the truth. During the 1990s, chemical grout, specifically acrylamide grout, was tested extensively by the Department of Energy and given a half-life of 362 years. At 362 years, chemical grout has the longest lifespan of any rehab product that is used in today's market. That is why we say when we seal a joint or a structure, we seal it permanently. As I said earlier, we tested 2,100 laterals using an average of 3 gallons of chemical grout in unlined pipe. We've seen that cured-in-place pipe, while being a very good structural product, is not a watertight product. The Army Corps of Engineers published that liners need to be sealed at both the lateral connections and at the manholes. This is due to the annular space that is present in cured-in-place pipe. Now, here we have a pipe that was that represents a pipe prior to lining, showing infiltration at the joints and at the lateral connections. When we line a pipe, we put a new piece of pipe in place from manhole to manhole. But what happens next is that we have to cut a hole in our newly installed seamless pipe. What's happening is that the joints and the fractures are still leaking. and the infiltration is finding its way back into the main line through the annular gap. Chemical grout works well with lining. Before the chemical gels, it has consistency of water, allowing it to not only penetrate the joints at the lateral connection, but also to be injected into the annular space, sealing the liner at the lateral connection. I've said that we used an average of 3 gallons of grout to seal in unlined pipe. It takes an average of 5 gallons to seal a lateral in lined pipe. Those extra gallons are going into that gap to seal the liner. Now, what's happening in this next slide is that the contractor did not forget to put the material in place before he laid the road. What it's representing is what is happening when you have infiltration. Not only do you have the added cost of treating the groundwater at the plant, you are also losing the substrates that are holding your pipe in place. Over time, infiltration weakens pipes. It allows them to shift and break, costing you 3 to 10 times more to repair than if you had taken the preventative measures in the first place. Taking a proactive approach will save you money. It will allow you to better budget your finances by eliminating future problems now. If you have a pipe with a lot of cracks and fractures, then you should line the pipe. But if you have a good pipe, you can grout it and prevent that damage from happening in the first place. The key is not sitting back and waiting for something to happen. That's reactive maintenance. Being proactive means getting to know your system, analyzing your pipes, fixing the immediate problems, and preventing future ones from ever happening. Grouting plays a large role in being proactive. NASCO and ICGA have published a set of specifications that will help you correctly put together a successful grouting project. In these documents, you will find the proper ways to test the equipment, what to look for when the joints are being tested, and the proper amount of grout needed to seal. Everyone here today will receive these documents as a takeaway. We teach our operators that they are there to seal that pipe, not just to pass a pressure test. Let me say it one more time. As a contractor or an inspector, your goal is to seal that pipe. Following the guidelines, working with the right contractor, being flexible, working as a team, all these things play a big part in making your project successful. Frank, I believe you're next.
Thank you, John. In this next section, we're going to talk about the process. Our process must be where we clean the pipe, perform a thorough inspection of the pipe joints and connections, assess the data, and make it a priority to determine a plan of action to rehabilitate by grouting or lining or replacing the pipe. If you choose grouting, then having a maintenance grouting program in place to visually inspect, test, and seal the joints from leaking is a proactive approach. Okay, well, what you're looking at here is a TV and seal truck, and you're seeing a manhole. You see the manhole winch, and you also see the hose system that is driving the packer and the camera. All right, so here we see a leaking pipe joint. We see the camera is in position, and the grout operator is going to use that camera to position the packer on the joint that's leaking. The bladders are inflated on either end of the joint, sealing that area, and then chemical grout is literally pressure injected through that joint out into the surrounding soil, and that's where the grout collar and seal takes place. Municipalities use different types of chemical grouts depending on the application. The acrylic family of grouts are preferred by cities and municipalities for sealing pipe joints, laterals, and manholes. The acrylic materials are preferred due to the low viscosity of the materials, that they are a true solution grout with no suspended solids, that you can get repeatable set times, and adjustable gel strength. In the early stages, grouting was said to be more of an intuition, a feeling, if you will. Today's grouters in the industry are leaning more heavily towards science. So in summary, here's what we've heard today. In past webinars, Avanti has featured very large communities and sewer districts, but today we wanted to focus on an average-sized system with typical problems, resources, and funding options. That's what Downers Grove Sanitary District represents, and they justified being proactive on maintenance to avoid more costly structural repairs. We heard how the engineering firm segmented the district into 149 basins to better assess and monitor with flow meters and provided measured results after the fact. From the contractor, the scope of the project was detailed and exceptions were noted requiring cooperation between the engineer, the district, and the contractor. Understanding the natural hydraulics within the sewer trench gives us insight on solving the problem through a systematic process and holistic approach to sealing the entire system. That's how you defeat infiltration and reward the rate-paying community with less cost, less fees, and far less disruption to the caliber of service they deserve and expect. And now we'd like to take the next 10 minutes for individual questions and answers. Robert, it's all yours.
Thanks, Frank. We have a lot of questions here and perhaps more questions than time, but our panel of experts have assured me that no question will be unanswered and that they will respond directly to each unanswered question by email so the dialogue on municipal chemical grounding can continue. I'd like to start off with this question, which really applies, I think, to all of our panel. And it says that many feel that the groundwater that was I&I at a certain location simply finds another place, another way to enter the system, the sewer system. How do you all feel about that, panel?
I would say you need to grout every joint and test the manholes within the area, just like we did over at the district.
Yeah, I would add to that that's why the district has divided their rehab work into basins. We do all the mainline and public right-of-way infrastructure first, monitor the results, and if additional I&I reduction is needed, then we go on to private property, and we have another separate program we could do another webinar on that is just focused on the private property.
Very good. Our next question is asked, do we know how much I&I was the result of leaks from storm sewers entering the sanitary sewer? Bob or Derrick, do you have an idea on that?
Well, we do know in those areas from doing dyed water flood testing of the storm sewers that we did have many locations where the storm sewers were exfiltrating and finding their way into the sanitary sewer. But I don't know, Derrick. I don't think we have a quantified result for each basin in that area.
No, we don't. We did do some SSES investigation work beforehand and did find some storm sewers leaking into it, but we don't have a quantified amount as compared to the whole amount of I&I.
Bob, we have several questions referring to the private property I&I work that you referenced in your presentation. And those questions are, does Downers Grove pay for the private property? And also they want to know how was this program started and kind of what kind of approvals did you need to get to be able to do work on private property?
Well, quickly, I can answer as far as paying for private property I&I work. Yes, we do pay for that. It's paid for through our service fee. We have our fee structure is where we have a user fee that is calculated by the amount of wastewater we process, but then we also do have a service fee on top of that funds the various programs that I had mentioned. And as far as the private property programs were started, we had the overhead sewer conversion program. That one was started back in '97 after a severe storm. Many people had flooding, and we're governed by a board of trustees. We were able to present a program to our trustees by which we could assist homeowners. That's actually a cost-sharing program, so it's shared up to a finite dollar amount at 50% with the homeowners. Currently, it's a maximum benefit of $3,000. Private property I&I removal program. There again, we approached our board with the repair programs, and they approved them. And we do have documents that we require to be executed, granting us access to the properties that get registered with the deed of the property, as well as a formal signed and notarized request by the homeowner for us to come on their property and do this remediation.
Thanks. Frank, this next question is probably best for you, but John, you may have a comment on it as well. And the question is, with the cost of contracting this grouting programs out, has there been a trend for municipalities to start their own chemical grouting program?
John, do you want to start and then I'll finish?
Well, I would like to say that I think it's a very bad idea as a grouter myself. Frank, being the supplier for acrylamide.
What we've seen, John, Robert, and to answer this question, is that I'm going to say in the early 90s, there was a big push by municipalities, local cities, to actually hire their own people, train their own staff, purchase their own grouting equipment, and do it in-house. And that probably was pretty consistent for the next 10 years. But I'm going to say in around 2004, 2005, there was a trend where they began to actually sub the work out to companies like National Power Rodding. They felt that they were gaining some expertise that their own team of people did not have, and just the varied experience that a company like NPR can bring on board. So I would say that it's kind of trending away from the cities doing their own work, but they are subbing the grouting work out.
Yeah, I'd like to add that you can buy a truck, you can kind of learn how the equipment goes in the ground, but once you get that far, experience starts to take over. Our guys have been grouting for quite a long time. We train our guys in-house. The Avanti also has a training school that they send that you can send your person to, your operators to. It takes experience to know what's happening with the grout. Once you see the grout, the ground taking too much grout, or it's not reacting right. Temperatures. There's a lot of different variations that take time to learn.
Very good. Bob, here's a follow-up question on the private laterals program. And this listener wants to know, how did you determine which laterals you would grout? Which one's got the priority?
Oh, okay. Well, what we did was in the area that we did the grouting of the service lines, because we had done an area previously where we lined the service lines from the house all the way to the public main. What we did is we did an inspection in each house. Our technicians went in, they did an inventory of the fixtures that were connected from the basement, sump pumps, ejector pits, that sort of thing, and then they televised the service line. Where we saw, 6-inch clay service lines with joints every 2 feet. In the area I was speaking about that we grouted, we saw lots of tree roots. We knew that those most likely were taking groundwater. So we just, anywhere we saw this 6-inch clay tile pipe, we scheduled those services to be grouted. There were a few that had houses in the area that had all PVC. Obviously, they didn't need it. There were also some that had iron pipe where we had the capability of doing a test where we could test them if we felt it needed But, in iron, if you don't see a lot of corrosion or any sort of discoloration of the joints, then you can pretty much assume it's not leaking. So I guess the short answer is where there was 6-inch clay pipe, those are the ones that we wanted to grout.
Yeah,
Very
if I
good.
could add real quick. On the AARA project, every lateral was tested, and those that failed were sealed.
Very good. Here's a question that's probably for Frank and John. This participant wants to know, is there different chemical compositions of grout for different types of pipe, such as PVC, ductile iron, concrete, vitrified clay, and so forth?
Well, I would first start out in saying we don't look at the type of pipe. We look at the type of ground and the type of substrates that's holding that pipe in place. That's what we're playing to when we're changing our formula, when we need to add in latex or we add in diatomaceous earth. We also look at what's happening in the pipe. As far as roots, we can add in a root killer.
Okay. We have another question, and this may be for Derrick and Bob. In your I&I analysis and flow monitoring, were perforated covers factored in, if there were any? And if so, what percentage does that play in your post-grouting I&I left to remove in the system?
Perforated covers, I'm assuming it means like an open graded lid. And the district did go through and do manhole inspections on all the manholes in the basins. And I would doubt there was any perforated covers or graded covers, and if there were, they'd have been immediately swapped out. I don't remember finding any. There could have been one or two, but I think there would be a very low percentage of those.
All right. Here's just a general question, and Frank, you may have the answer for that. How much I&I is estimated coming from private property? I assume they mean across the U.S.
I can take that one. We've looked at a number of basins in Downers Grove and actually in other communities as well, and it does vary, but it seems as if the amount of I&I on private property is somewhere in the 2/3 to 80% range of the I&I. We've done 4 comprehensive basins in Downers Grove where we've sealed up everything, private property all the way to the house and mains, and we do it in stages so we can measure the incremental success. And in those basins, right after we do the main lines, we're reducing about 20%, and then the other 80% is on private property. So I'd say somewhere in the 2/3 to 80% range.
Okay. And then here's another question that probably is for most of the panelists. It says the joint failure rate in this presentation was stated at about 25%. Was every joint grouted or just the ones that failed?
Well, you can only grout what fails. What we do is we test the joint first, pressuring up an air test, depending upon how deep the ground is, on average about 15 psi. If that joint does not fail, if it holds the air, it's a pass joint. It passes. If it fails, what happens is the air escapes through the joint into the surrounding ground. That's where we pump the grout. The grout actually goes onto the outside of the pipe, and it seals the pipe from the outside in. When we're done, we don't see any grout at all within the pipe itself.
Very good. As I suspected, and we talked earlier, we have lots more questions, and the panel will answer those. We're just about to run out of time. We have a little bit more housekeeping to do here and a little more wrap-up to proceed with. We're going to go into our third and final interactive polling question, but as promised, I want to give you the results of the second question, which was, what rehabilitation method do you have the most experience with? Not unexpected was that dig and replace came in at 39%. though I can tell you we do extensive surveys here at Underground Construction on an annual basis, and the amount of dig and replace has dramatically dropped over the last several years, as one might suspect, with the advent of rehabilitation technologies becoming much more prevalent in districts' efforts to maintain their system. So the dig and replacement came in at 39%, lining at 25%, and chemical grouting is up to 14%, and I believe that is an increase in recent years. So that's, I think, very reflective of the industry. So on to our third question, which is, why do you believe there is a resurgence in the chemical grouting industry we just referenced? Is it because chemical grouting is the most cost-effective non-structural repair? Is it because proven long-term solution or complementary to other rehab technologies, or all of the above? So basically, why do you believe there has been a resurgence in the chemical grouting industry? And we'll try to get those results to you here shortly as well. But we also have some promised documents to all participants, and we think that they will complement this webinar quite nicely. We sincerely hope you found this webinar beneficial, and we've really enjoyed presenting the information and working with our online audience. As promised, all participants will receive 2 bonus documents, a white paper on the role of chemical grouting in wastewater systems, and the new suggested standard from NASCO and the Infiltration Control Grouting Association. You'll receive these important documents within 24 hours of this event. And in the future, you can learn more about Avanti and grouting applications at the annual UCT conference, January 28th to 30th in Houston. That's the Underground Construction Technology Conference. Avanti will not only be exhibiting, but they are also a proud sponsor and participant in the renowned Rehab Zone held each year at UCT. It's a great opportunity to learn in a non-selling environment, and hope you all can come to that. For those of you wanting to receive CEU or PDH credits for this webinar, please send the following information to Aaron Nelson Perek. That's E-Nelson, E-N-E-L-S-E-N, at oildom, OILDOM.com, and send the information referenced up there to the email reference up here on the screen, and we will get you out. We partner with the University of Texas, Arlington, and they will take care of getting you your PDH or CEU credit. We also want to remind everybody that to hang on for a minute after we do our wrap-up here, because we're going to replay that animation. I understand several people were unable to see that animation of Frank Aguilar's, and Frank's going to stick around for a minute and narrate it again and let you all see that. So it'll just take a minute. And now we want to wrap things up, and here at Underground Construction Magazine, again, I'd like to thank Avanti and our panel of experts for providing such excellent information about the grout in the marketplace. So with that, we're just going to take a minute for just some brief parting comments from today's speaker. And Derrick, let's begin with you.
I'd just like to thank everyone for attending today and comment that whenever we're starting a rehabilitation project, we consider all the different options, and that grouting has been very successful when applied to the correct application.
Bob?
Oh, yeah. No, yeah, thanks, everybody, for the opportunity to share our experiences, and I agree. Grout is it's a cost-effective maintenance tool for the right application.
John?
I can probably speak for all of us in saying that we thoroughly enjoyed putting this hour together for you guys. I think it can be said that if you learned one thing from this presentation, then all of our efforts to put it together were well worth it.
And Frank?
Thank you. We encourage everyone to learn more about their utility trench systems, keeping in mind that being proactive lessens the amount of reactive repairs we'll face, and that chemical grouting is a complementary technology to lining and other alternatives.
Thank you, gentlemen, very much for all that valuable information. And to our listeners and participants out there, as you exit this webinar, you're going to be asked to participate in an exit survey. It's very brief, but it's one that Avanti designed, and because they value immensely your opinions and your insight towards future webinars. and they'd really like for you, if you don't mind, to please take another minute to complete this survey, because this will really help direct future efforts. So thanks again for this last hour of your time, and I trust you found it time well invested.